Hello everybody, now I'm going to teach you how to solve polynomials, or basically find all the roots. Alright, given this example, the first thing I'm going to do is identify my degree and the number of roots I have. Well, my degree is 3, so that means I'm going to have 3 roots. The second step is to find all the possible rational roots. And so my last term is p, and my leading coefficient is q. So of course when I write all the multiples of p and all the multiples of q and divide them out, this is what I get. Now, if you don't understand this step, you can go back and look at my 2 previous videos on how to find all the possible rational roots. All right, now I'm going to type this function in the calculator and graph it, and it looks like so. And I'm going to choose a root. I'm going to choose -4. So that will be the root I will use synthetic division for. I'll go ahead and write all of my coefficients of my polynomial and do synthetic division. Bring down my 6, multiply to get -24. Add straight down, I get 7. Multiply to get -28. Add straight down, I get -5. Multiply, I get 20. Add straight down. All right, so therefore, my function is going to be 6x squared plus 7x minus 5. All right, the next step is to identify your a, b, and c so that you can plug it into the quadratic formula. So it would be -7 plus or minus 7 squared minus 4 times a times c all over 2 times a. And when I put everything that's under that square root in the calculator, I end up with 169. And I'll just bring everything else down. And 2 times 6, of course, is 12. Well, the square root of 169, that is a perfect square. It equals 13. So therefore, I have -7 plus or minus 13 over 12. Since I do not have a radical after finding the square root, I can actually split this up into -7 plus 13 and -7 minus 13 all over 12. So my root will be -7 plus 13, which is 6 over 12, and -7 minus 13, which gives me -20 over 12. And you want to make sure that you reduce all of your roots if you can. So the first one's going to reduce down to 1/2. Second one's going to reduce down to -5/3. And of course, you can't forget the first root that you chose, which was -4. So these are all of my roots. Now, to write the complete factorization, of course, it's like going backwards, making them equal 0. So this first one's going to be x plus 4. Second one's going to be 2x minus 1. And the last one's going to be 3x plus 5. Again, if you don't know how I got these, I have a separate video on how to find the complete factorization. And that's it.